So 9.10 notes. This is finding x values when you're given a percent. So our learning target today is to find any value when you're given the percent. To do this on your calculator, you're going to go second distribution, inverse norm. So instead of number 2 like yesterday, we're going to go down to number 3. Okay. You're going to be asked for 3 things. The area. So you put the percent you're given as a decimal, and then the mean and standard deviation. If you're given the percent above a number, the area has to be 100% minus the percent above that number as a decimal. Your calculator only understands the area below a number, not above, with the mean and standard deviation. If you're trying to find 2 numbers, you have to do this twice. Once for the low number and then once for the high number, because you can only do 1% at a time. So if you are doing normal CDF, it's if you're trying to find the percent. This was what 9.9 lesson was. You use inverse norm if you're given the percent. So this is the difference between the two. If you're trying to find the percent, normal CDF. If you're given the percent, it's inverse norm. So scores on the Wechsler Adult Intelligence Scale, a standard IQ test for the 20 to 34 age group, is approximately normally distributed with a mean of 110 and a standard deviation of 25. Albert Einstein is said to have an IQ score of 160. What is his percentile? So you have to fill in the chart. So you have a mean of 110, so that goes in the center, and then the standard deviation is 25. So you're going to add 25 and then subtract 25. Notice we're given Albert Einstein has a score of 160. We're looking for his percentile, so that's the percent below the number. Since you are trying to find the percent, that means we're going to do normal CDF. Normal CDF does not ask for area. Instead, it asks for the lower, upper, mean, and standard deviation. So the lowest number shaded is negative a billion. The highest number shaded is 160. Your mean is 110, and your standard deviation is 25. Then you go second distribution, normal CDF. You type this in and paste. To find the percent, you have to multiply it by 100, and you should get 97.72%. So this is just like 9.9. In part B, it says, what score would you need to be in the 75th percentile? So notice this time you're given the percent. I can't mark the 75 on the chart because I don't know what score that would have to be. I know I have to do better than 110 because that's the 50th percentile. So what we're going to do is kind of shade and take a guess here and say this is the bottom 75%. That's the 75th percentile. Notice we're looking for a number. So, and we're given a percent. When you're given the percent, it's inverse norm. So you're going to put in the area, the mean, and the standard deviation. So the area is always percent below the number you're trying to find as a decimal. So this is going to be 0.75. The mean is 110. The standard deviation is 25. You go second distribution, this time inverse norm number 3. And you type that in. You hit paste. You're not going to multiply by 100 because this is not a percent. Instead, it's a score of 126.86. And then you're going to mark that in your picture. So on your work, you have to show shading below the number, marking the percent, writing out the area, mean, and standard deviation, and writing the score twice. Once out here is the answer, and once in the picture to show where it is in the numbers. Mensa is an elite organization that admits people who score in the top 20% on IQ tests. What score would an individual have to earn to qualify for Mensa membership? So you're wanting to find what score in the top 20%. So that means we have to shade the top 20%, but we don't know what number to go to. Again, when you're given the percent, it's going to be inverse norm. So you're going to do the area, mean, and standard deviation. The area you type in has to be the percent below the number you're trying to find. And since this has to add to 100%, our area is going to be 0.8. Our mean is 110. Our standard deviation is 25. You type that in, you should get a score of 131.04. And then mark it in the picture. Number 2, high levels of cholesterol in the blood increase the risk of heart disease. For 14-year-old boys, the distribution of blood cholesterol per deciliter of blood is normally distributed with a mean of 170 and a standard deviation of 30. So let's fill in our picture. We have a mean of 170 and a standard deviation of 30. So you're going to add 30 and subtract 30 from the mean. Part A says, what is the first quartile of the distribution of blood cholesterol? So first quartile, remember a quartile is 25%. Since it's the first one, it's the bottom 25%. So we're going to kind of shade the bottom 25%. Since you're given a percent, it's inverse norm. So you do the area, the mean, and the standard deviation. The area below the number you're trying to find is 0.25. The mean is 170. The standard deviation was 30. You type it in, you should get 149.77, and you should mark it in your picture. Part B, a doctor tells his patient he's in the 60th percentile. What's his blood cholesterol? So 60th percentile is the bottom 60%, so somewhere around here. You're given a percent, so it's inverse norm. The area below the number you're trying to find is 0.6. The mean and standard deviation, you should get 177.6 and mark it in the picture. Okay, number 3. Scores on the math portion of the SAT exam in 2013 form a normal distribution with a mean of 506 and a standard deviation of 115. What is the minimum score necessary to be in the top 15% of the SAT distribution? So go ahead, give this one a try. Hopefully you caught that if it's the top 15%, you have to type in 0.85 as your area and got 625.19. I'm going to go ahead and skip the rest of this lesson. So go ahead and start your homework.